Guys, so we are going to play Name That Property. So it is your job to come up with the properties that these guys illustrate. On your homework assignment, you're going to be asked to do this. You're going to be saying, hey, what does 12 plus 917 equal 917 plus 12? What property shows me that this is a true statement? Because again, what properties are, they're rules. They are rules. They say, hey, look, you can do this. I can switch these numbers around and still come up with the exact same answer. Okay? So what property is this? Well, if you need to, go back. Go back and look at our properties. We have the identity properties. Well, that doesn't really look like identity, does it? Property of 0 multiplication. Well, there's no multiplication on here, so fairly safe bet that it's not anything with multiplication. Let's look here. Commutative property or the associative property? Well, associative means that we stay in the same, right? But commutative property, which we talked about in the previous video, said they flip, but they still give you the exact same thing. Okay, cool. So these guys flipped, right? They switched places. So this would be the commutative property. Okay, that's cool. Commutative property. But don't forget, you're going to tell me what operation this is. So it's the commutative property of addition. Awesome. All right, so now if I look at this one, well, the same thing is happening, right? They flipped spots. So what property is that? Good, it's the commutative property of multiplication. Sorry for writing sideways. We have slides right now that I need to get going vertically, not horizontally on paper. Addition. Oh, is it addition? Nah, that's what? Multiplication. Gotta catch yourselves too, guys. Get so in the habit of writing addition, and it's not addition, it is multiplication. So these will probably be 2 points on your homework assignment. You put commutative property, that's 1 point. Tell me that's multiplication, that's 2. So if I look at this one, okay, well, nothing's really changing here, but this is kind of cool. I have m plus 0 equals m, so I'm getting it itself on the other side. So what property means that I'm getting it itself on the other side? Good, it's identity. Identity. Identity, and if I could spell, that would be totally ideal, wouldn't it? But you guys all know my spelling abilities. They're not the greatest, but we're working on it. Identity property of addition. Again, it's important to put the word addition in there. Alright, so let's take a look at another one. Again, we're still playing Name That Property. Well, we have -1 times n equals -1. Nothing's really changed, so that takes out the commutative property. There's not 3 numbers, so that takes out the associative properties, because associative properties has to have at least 3 numbers. Okay, so identity, well, I'm getting the opposite of it, so it's really not identity properties. And it's not property of 0, so it has to be the multiplication property of -1. So this has to be the multiplication property of -1. Again, it is okay to go back and view your notes, ladies and gentlemen, but when it comes to be test time, you're not going to have your notes there. So it's really important to write out note cards when it comes to these. If you don't know these by heart, I would write out note cards. I would study these because these are not going away. All right, and I guarantee you, you'll have a couple EOC questions that are going to be saying, hey, what property does this illustrate? And you're not going to have any cheat sheet on there. All right, you're not going to have a cheat sheet that tells you the properties. You're going to have some that tells you the formulas, but you're not going to have anything that tells you the properties. So you really have got to know these properties. It's kind of like a vocab term. You got to know them. Okay? What's happening here? Well, there's 3 of them, and it's addition, and they're not changing their order. They're just changing their grouping. So what property means a grouping? Good, it's dissociative. Dissociative property. And please do not abbreviate that. Please do not abbreviate associative. Just write it out. Associative property. And what operation is it? It is addition. So it's associative property of addition. All right. So looking at this, k times 1 equals k. Well, that's identity, isn't it? What identity property is it? Good, it's identity property of multiplication. Identity property of multiplication. Whoops, sorry. Identity property of multiplication. Again, it's important to put down there that it's multiplication. Although you may say, well, Miss Burr, it has a star there, so it's multiplication. You should know it's multiplication. Yeah, you're right. I do know it's multiplication, but I don't know if you know it's multiplication unless you write it down. Okay? So please write it down for me. All right? Show me that you know it. All right, use mental math. I use mental math all the time when it comes to things that I do, just because it's a lot easier. It's less time consuming. It is one of those things where it's, hey, look, if I'm going into the store, it's going to be a lot easier to use mental math to figure out what's going on instead of pulling out my calculator on my phone. And you know, what if somebody calls me on my phone and I don't have access to a calculator because my calculator is my phone, but I really want to talk to this person and still kind of keep track of what's going on. So you got to think about it that way too. And sometimes I really don't even carry my phone in. Sometimes I just want to be in the store just to walk around and clear my head instead of worrying about everything else. So anyways, using mental math is a real easy way to figure out things a little bit quicker and not rely on technology, rely on your brain cells. So if I look at this, if I add these in order, again, it's not going to be that bad because these numbers aren't that crazy. I mean, we know that 36 plus 12 is 48 plus 4. That gets a little bit iffy because I got a carry, right? If I was doing this longhand, I would carry 1 over because 8 plus 4 is 12, and I have to remember to carry that 1. But is there a way that I can do these, there's a way that I can add these up and not have to worry about remembering to carry a number? Good. If you're saying, hey, look, if I take 36 plus 4 first and then add 12, then I'm going to come up with 36. What's 36 plus 4? That's 40. Plus 12 is 52. Okay, so what gave me that right? What gave me that right to say that 36 plus 12 plus 4 is 36 plus 4 plus 12? Well, what happens with the 12 and the 4? They just flopped, didn't they? So what property gave me that right? The commutative property. Commutative property of addition. And make sure I'm spelling these right. Oh, nope. Commutative. I always want to put extra letters in here. Commutative. Commutative property of addition. Okay. Commutative property of addition. Commutative. Okay, so then what did I do? I simply just added, right? I added straight across, just like we're told in PNDOS 2. After I flipped them, I added straight across. So simply I added, and then I added here as well. Okay, so what did I just do by writing this out, by telling you guys my steps? I literally just justified my reasoning behind this. And we're going to talk about that here in a little bit. I literally told you why I could do what I was doing and what rules support my thinking on this. So when we do some of you guys' problems today, I'm going to be asking you, okay, so what gives you the right? What gives you the right to add, in this case, 36 plus 4 first? When PNDOS, if you remember, PNDOS says we do addition from left to right. So what gave you the right to switch them? Well, the commutative property did. The commutative property tells me, hey, I can switch them and I'm good. And I can add the rest of it. Okay, so let's look at this guy. All right, so right off the bat, you're thinking, hey, 2 times 16 is what? 32? Or 22? What is 2 times 16? It gets a little bit shaky, doesn't it? Okay. 5 times 10 is 50. That's not bad. So I could go that route. But is 2 times 16 going to be something that I can easily do in my head? No. And by the way, it's 26. Or 22. Wow. It is 22. Because 16 times 2 is 12. Carry the 1. No, it's 36. 30. It is 32, folks. Yeah, you see how confusing that could be if I was trying to be in the store right now, figuring that out? It's not practical. Alright, so how can I go ahead and do mental math with that? What can I do? Well, we can rotate these around. Okay? Again, I could take, and I would do 2 times 5 first. I would do 2 times 5 times 10 times 16. The reason being, what's 2 times 5? 10. So we have 10 times 10 times 16. What's 10 times 10? Good. 100 times 16 is 1,600. So I could have done 50 times, or 10 times 5 and then times 2. But I'm one of those people that if I can get tens, if I can get zeros on the end of things, that's going to make my life so much easier. Because if there's zeros on the end of things, then I just have to tack those on, right? So again, what gives me the right? Well, the commutative property does. Commutative. Wow. AI. Property of multiplication. All I did was change the order of these. Multiplication. Some people will tell you that the associative property was probably involved in here too. Yeah, if you want to get technical. But really, all I did was switch the order around. So really, The community property was probably the best for this, in my opinion. Less hassle, less work. Looking at these two, then all I did was simply multiply using PEMDAS. So again, multiply. And as well here. That would be my justification on this, if I was actually having to write this out. But I'm not, because it's supposed to say mental math. It says mental math, so I really just want that number. Okay? So that includes the mental math and the name of that property.